Hello and welcome. In our lesson today, we are going to discuss another factor that affects the rate of a reaction. This is surface area. Now generally, if you have a reaction whereby one of the reactants is a solid, the size of that solid affects the speed at which the reaction takes place. So if you have, for example, a solid that offers a large surface area, then you're going to have a faster rate of a reaction. If you have a smaller surface area, then the reaction is going to be slow. Now let us look at the diagram that we have on the board. In the first instance, we are having a solid in form of a huge lump, just one big block. Now you can see the smaller particles, those are the other reactant. So let's imagine those are the particles of a certain solution. Now because we have the solid in one big form, the reacting particles of the solution will have a smaller surface area of the solid that they will come into contact with. So what will this mean? Simply means that the rate at which the effective collisions will happen will be less. So the reaction will be slow. Now if you were to take this solid, break it down into smaller particles, you will be exposing more of the surface area, more area of the reactant coming into contact with the particles. So this will in turn speed up the rate of the reaction by increasing chances of the reacting particles having effective collisions. Now, in this factor, or for this factor, we are going to discuss two examples related to it. Now, in the first example, we are going to talk about the reaction of zinc metal with hydrochloric acid. So what will happen is that we are going to take zinc, react it with hydrochloric acid to form zinc chloride plus hydrogen gas. Now, the hydrochloric acid used will have the same volume and the same concentration. The difference will be in the form of zinc metal used. So in the first instance, zinc is going to be in powdered form. In the second instance, we are going to have zinc granules. These are small pieces of zinc metal. About the expected observations. Now in the first instance, we are going to expose a larger surface area of the zinc metal coming into contact with the particles of hydrochloric acid. So we are going to have a faster rate of reaction. That means that the production of bubbles or the production of hydrogen gas is going to be faster in this instance. In the second one, we are reducing the surface area of the zinc metal coming into contact with the hydrochloric particles. Therefore, we are reducing the speed of the reaction by reducing chances of effective collisions happening. Now let us observe to see whether this is actually true or not. Okay. And there we have it. So as you can see, we are having a faster rate of effervescence in the first one compared to the second one. Why? Because we are increasing the surface area by using powdered zinc. Now another common example that students are usually tested with is that of the reaction of calcium carbonate with hydrochloric acid. Carbonates react with acids to form three products. We are having a salt, carbon 4 oxide gas and water. So in this case, you're going to form calcium carbonate, water and carbon 4 oxide. So again, with this reaction, you're going to determine the rate of the reaction by simply determining the amount or the volume of carbon 4 oxide gas produced over a certain period of time. Now let's imagine we have two forms or two types of calcium carbonate used in this reaction. We are having powdered calcium carbonate, or what is called marble, powdered marble, and in the other case we have marble chips. So these are small blocks of calcium carbonate. So again, powder, we are increasing the surface area. So we are going to get a faster rate of reaction. That means that more carbon 4 oxide gas is going to be collected in a shorter period of time compared to that of the marble chips. So if we were to represent this information using a graph, that is what we're going to have. So as you can see, the curve representing the powdered calcium carbonate is steeper compared to that of the marble chips. This means that more carbon 4 oxide gas is collected within a shorter period of time. Why? Because we are exposing a larger surface area, increasing the effective collisions, which in turn increases the rate of the reaction. Now, one thing I'd like you to note is this. The two curves level off at some point. They flatten out at some point. Now, the reason they do this is because the amount of carbon 4 oxide gas, the volume of carbon 4 oxide gas produced in the end is equal in both cases. Now, this will be equal because the reactants, the mass and the volume of the reactants used in both cases is the same. So we are going to collect the same volume of carbon 4 oxide gas. What will be different is the time taken. So the time taken will determine whether the rate of reaction is faster or slower. So up to that point, we are done with the first part of our lesson. Let's proceed to past KCSE questions to test our understanding of this concept.
Our first question is from 2002, paper 1. State and explain how the rate of reaction between zinc granules and steam can be increased. So zinc reacts with steam to form zinc oxide plus hydrogen gas. Now zinc granules are solid chips of zinc. So that means that if we want to speed up the rate of this reaction, we can simply use a different form of zinc, and this is zinc powder. By doing so, we are increasing the surface area, therefore providing a larger area in which the molecules or the particles can come into contact with one another, bringing about effective collisions. And that is it, using powdered zinc, which will provide a larger surface area. Our second question is from 2012, paper 2. The factors which affect the rate of reaction between lead carbonate and dilute nitric 5 acid were investigated by carrying out 3 experiments. So we have 3 experiments, 1, 2, and 3. In experiment 1, lead carbonate in lumps was reacted with nitric acid having a concentration of 4 molar. Experiment 2, powdered lead carbonate was reacted with 4 molar nitric acid. And lastly, in experiment 3, we are having lumps of lead carbonate reacted with nitric acid having a concentration of 2 molar. So we can clearly see that there are 2 factors over here. We have a difference in concentration of the acid. We also have different forms of lead 2 carbonate. Part A, other than concentration, name the factor that was investigated in the experiment. And this is surface area. For each experiment, the same volume of acid, excess acid, and mass of lead 2 carbonate was used, and the volume of gas liberated measured with time. Roman 1. Draw a setup that can be used to investigate the rate of reaction for one of the experiments. So that means that we are going to need a setup that includes a method of collection of the gas. And remember, whatever apparatus that we use to collect the gas needs to have calibrations so that we may know the volume of the gas collected. And this is as such. Part 2. On the grid provided, sketch the curves obtained when the volume of gas produced was plotted against time for each of the experiments and label each as 1, 2, or 3. So we are going to have 3 curves as such. Now I want us to discuss which curve is going to be attributed to which experiment. Now if we look at the information provided on the table, we can see that there are different concentrations of nitric acid used. So the one that will have the fastest rate of reaction is the one that will have a concentration of 4 molar. Now there are actually 2, experiment 1 and experiment 2. But the difference between these 2 is that experiment 1 is in form of lumps, lead 2 carbonate is in lump form, and in experiment 2 is in powdered form. So that means that if we have powdered lead 2 carbonate together with the high concentration of nitric acid at 4 molar, this will give us the fastest reaction out of the 3. So it's going to have the steepest curve. Now the second fastest reaction will be of experiment 1. Now experiment 1 and 3 both have lumps of lead 2 carbonate. The difference is that experiment 1 uses 4 molar nitric acid while experiment 3 uses 2 molar nitric acid. So therefore, the second fastest reaction will be experiment number 1. This will have the second steepest curve. And the slowest reaction of the 3 is going to be experiment 3 because the lead 2 carbonate is in lumps and it has the lowest concentration of nitric acid. Roman 3. Write an equation for the reaction that took place. And there we have it. Lead 2 carbonate reacting with nitric 5 acid to form lead nitrate plus carbon 4 oxide plus water. And that is that. So this brings us to the end of our lesson. I hope you have benefited a lot from it, and I'm hoping to see you next time.